Hello everyone, this video is about carbonyl chemistry. This is carbonyl chemistry part 2 video. Now here I will discuss about adduct formation reactions of carbonyl compounds. First of all, hydrate adduct formation. Here what happens when water is added to a carbonyl compound? Does water react with carbonyl compound? The answer is yes. When there is water in the medium and carbonyl compound, then water will attack to the carbonyl carbon, and in that case we are taking here a aldehyde group. Now if water attacks to carbonyl carbon, then this double bond will open and O negative will form. Now in the next step, that O negative will capture a proton and 2 OH will form, and that compound is known as diol. This is the hydrated product or hydrated adduct of carbonyl compound. This is possible in case of aldehyde. Actually, simple aldehydes are hydrated to some extent, but simple ketones are not. What is the reason? In my previous video I told you here, if electron donating group present here instead of hydrogen, then suppose here CH2 group is present, then CH2 group has plus I effect. If both groups are CH3, then two groups will show plus I effect, which will increases the electron density of that carbonyl compound. That will decreases the tendency of nucleophilic attack. So in that type of reaction, water will attack to the carbonyl compound, and for aldehyde this is happened some extent, but for ketone this does not happen, because as we know aldehydes are more reactive than ketone. But why is this is not possible in case of keto compound? The reason is that equilibrium, because keto is less reactive and it is more shifted towards the keto form, but special factors can shift the equilibrium towards hydrated side even for ketone. This is possible if the ketone compound is unstable or very much reactive. Now, formation of cyanohydrin. In cyanohydrin formation, we have HCN present in the medium. That HCN will go to H plus and Cn minus, H proton and cyanide ion. That Cn negative will act as a nucleophile, as negative charge on nitrogen, and it is a very good nucleophile. Now in next step, Cn negative will attack to that carbonyl compound, and similarly the double bond will open. Now as double bond opens, then O negative will form. Now H plus present in the medium, and that O negative will capture that proton, and the next step that will form, and this compound is named as cyanohydrin compound. Here in that case, as cyanohydrin is reacting as a nucleophile, and here in the redetermining step both substrate and nucleophiles are involved, so that rate will be rate constant into substrate into nucleophile. So rate of this reaction will depends on both that keto compound and the nucleophile compound. Here R prime and R can be hydrogen, methyl, any aromatic group, anything. Now as a substrate, then what will happen? In this case nothing will happen. Cyanide will not attack to that carbonyl carbon. This is because that a OR group present in ester, the lone pair of oxygen will go to resonance and it will form this, and because of that resonating effect or plus R effect of OR group, the electrophilicity of that carbonyl carbon decreases. And as I told in my previous video, if an electron donating group present with carbon, then nucleophilic attack will not occur or tendency of nucleophilic attack will reduces. Here that is occurring, and cyanide will not attack in case of ester compounds. Now some of the applications of attack of cyanide group to a keto compound or carbonyl compound or aldehyde compound, that is acetaldehyde and ammonia reaction. In the reaction of acetaldehyde and ammonia, aldehyde will form. How? Here acetaldehyde present and ammonia present and aldehyde is forming. How is that formed? Here acetaldehyde is reacting with ammonia. Ammonia with its lone pair will attack to the carbonyl carbon, and it will then that O negative will take the H plus from the medium or from NH3 positive group. Then here OH, NH2 and hydrogen. Then a water will releases and forms that imine compound. After formatting that imine compound, it will react with another group of imine. Actually it will react with 3 group of imine and the aldehyde compound forms. NH, NH, this is the reaction pathway, and through that process, through that imine compound, this reaction will occur, and this cyclization occur and aldehyde forms. Now another application of cyanohydrin formation is Killiani method of ascending sugar. We can form a sugar with more number of carbon by this method. Here a sugar is reacting with cyanide group and it will form a cyanohydrin here. After formation of cyanohydrin, by application of those reagent, barium hydroxide dilute H2SO4, then heat, then at pH 3 to 5 sodium amalgam H2SO4 to reduce the compound, and we will get this sugar, and this sugar have 1 2 3 4 number of carbon, whereas this final sugar has 1 2 3 4 5 number of carbon. So this is the Killiani method of ascending sugar. Now I will go for acetal and ketal formation. For acetal and ketal formation, we need a alcohol in a medium, and here ketone or aldehyde is present, and then that alcohol, similarly the lone pair of oxygen will attack to the carbonyl carbon, and that double bond will open some and O negative will form. That O negative will take a H plus from medium, and then this compound will form. Now if in the medium more alcohol is present, then again another alcohol will attack here, and it will releases OH as H2O, and then another group of OR double prime will be added, and here here another OR double prime group is added. Now if this type of compound forms with a OR double prime and with a OH group, then we can call is hemiacetal when R prime is equal to hydrogen. When the substrate is aldehyde and after reacting with alcohol, one OR double prime group and one OH group is present, then we can call it as a hemiacetal compound. If the initial substrate was not an aldehyde, if the initial substrate was a ketone, then we will call it Ketal. Then after reacting with another molecule of alcohol, another OR double prime group will be added, and then here in that compound two OR double prime groups are present, and this is called acetal when the substrate was aldehyde, means when R prime or R is equal to hydrogen, and this will call ketal if no hydrogen is present in place of R or R prime. If the substrate was ketone, then the final product will be ketal. If the substrate was aldehyde, then the final product will be acetal. Now application in blocking of diol. That acetal and ketal formation can be applied in the blocking of diol. How? This is a diol. Two OH groups are present in adjacent carbon, and this is reacting with the acetone in presence of H plus, and it is forming a ketal. Now another adduct formation is sodium bisulfate adduct. If in the medium sodium bisulfate group is present, then sodium bisulfate adduct will form. What will be the nucleophile here? Here in the medium sodium bisulfate is present. This is sodium bisulfate and it will dissociate in sodium plus and HSO3 minus. Then again in the medium water also present, and in the next step HSO3 negative will react with water and it will give you H2O plus and SO3 negative, and here SO3 negative will be the nucleophile, and the structure of SO3 negative is like sulfur double bonded O, O negative, O negative. Now the question is, which is the nucleophilic center here? Here that compound can attack through O negative or through sulfur also. So it will attack through sulfur because sulfur is higher in nucleophilicity than oxygen, because sulfur has a larger size and oxygen has a lower size. So the charge density is lower in sulfur and higher in oxygen, as because of higher size of sulfur is higher in nucleophilicity than oxygen. So the reaction will occur through sulfur atom. Now what will happen? Let's see. Here is the ketone or aldehyde. Always aldehydes are more reactive than ketone. We have to keep it in our mind. And now that attack will occur through sulfur. Sulfur has lone pair. It will attack through sulfur and it will attack to the carbonyl carbon, and O negative will form. And as the previous steps, here O negative will form, and in the next step protonation will occur to the ketonic or aldehydic O negative. So protonation will occur to the carbonyl oxygen, and in the medium we can see in the medium H2O plus is present, and H2O plus will give you H plus and H2O, and from medium O negative can takes this H plus, and the next step that will form, and this is the sodium bisulfate adduct. This is sodium bisulfate adduct. So this was about addition reactions. In my next video, I will discuss about more reactions of carbonyl compound and many important reactions which are also important for many competitive exams. So Thank you for watching, and please like, share and please subscribe to my channel.